Okay, this will be the introduction to the white blood cells, which is lab 23, and very closely associated, obviously, with lab 22, which was the red blood cells. So looking at the white blood cells, corresponds to Fox 6.2, and we would do a total white blood cell count, what's called a differential white blood cell count. Just a quick review of blood components. The blood composition is made up of basically a liquid portion and a solid portion. The liquid portion of blood is called plasma. It makes up 55-60% of the blood. It primarily is water and dissolved stuff. That dissolved stuff would be ions, nutrients, gases, so sodium, potassium, calcium, chloride, glucose, fatty acids, things like that, as well as gases like oxygen, nitrogen, CO2. The solid portion is called the formed elements. They're generally cellular elements, but they're not usually completely cells. And that makes up the difference between the 60% of the liquid and the 40% of the solid. So if you had plasma was 50, then the formed elements would be 50. If the plasma was 55, the formed elements would be 45, and so on. Within the formed elements, there are three important blood types, and then for the one blood type, subtypes. So we have the erythrocytes, which are the red blood cells. They make up 95% of your formed elements. As we saw in lab 22, they make up about 5 million red cells per microliter of blood. Today we're going to look at the leukocytes. The leukocytes are your white blood cells. Leuko literally means white, as erythro means red. Leukocytes make up about 5,000 to 10,000 per microliter of your blood. So they're order of magnitude, basically a 1,000 times less of the red cells. So typically an average person has 500 to 1,000 red cells, and for every one white cell that they have. So they're much, much fewer. Thrombocytes are your clotting cells. They are also known as platelets. You have a couple 100,000 of them, 200, 400,000 typically, but they're cellular fragments, so they make up a small part as well. So when we spin that whole blood in a centrifuge, like we saw in lab 22 to figure out the hematocrit, then the middle portion is called the buffy coat, and it's made up of the leukocytes. It's very small because there's very few of them, and the thrombocytes, that's very small because they're very small physically in size. So the vast majority of your formed elements from a cellular component are in both percentage and volume are your red cells, right? But today we're looking at white cells. So when we look at your white cells, you can divide your white cells into a couple categories. The white cells we can generally divide into what we call granulocytes and agranulocytes. Granulocytes have granules in the cytoplasm. So in these drawings here, right, they're not photographs, right? They're just drawings. You can see all the little dots. So this has got granules, this one's got granules, and this one's got granules. So we see three of the cells that have granules. This one, it's hard to tell. It sort of looks like it has granules. That's not granular, and this one is not considered to be granular. So we can divide up the white cells, or the leukocytes, into two groups. The ones that have granules, those are called the granulocytes. Notice all of the granulocytes, neutrophils, eosinophils, basophils, all end with the last name phil. So that's what they have in common. The agranulocytes, A meaning without, end in cytes. We have monocytes and we have lymphocytes. So there's two of those. And they're going to be important to be able to tell the difference between each one when we do the experiment. We'll come back to that. So I just want to make sure we have those pictures. So we're going to do the same thing we did before to some extent. Again, we have the blood safety handling procedures we'd go over in class if we're doing it in class. And you do a total white cell count in a very similar but few major differences in terms of the ways we do it as the red cell. We're going to get a small centrifuge tube, but this time it's going to be blue. So it's going to have a methylene blue dye in it. So we know there's a difference between the red cells and the white cells. The difference is that the chemical inside of this one would lyse the red cells. The one we did the other day with Lab 22 lyses the white cells. This one lyses the red cells. So the only cells that will be left will be the white ones. The other difference is, since white cells are fewer, we need a bigger volume to get an accurate count. So when we measure the hematocrit tube, we're going to have one that's a little wider, although it's hard to tell, virtually impossible to tell if you're just looking at them. That would hold 20 microliters of solution. And again, it'd be small enough, it'd be short enough where you fill it completely, no air, drop it into this tube, 20 microliters, shake it up, let it do its thing in lysing the red cells, and then you're going to add it to the hemocytometer. It's going to be the same thing we did before. You're going to have a cover slip on, you're going to go to those little notches, you're going to fill up each side with blood and the solution, and then you're going to take it and you're going to throw it under a microscope and you're going to look at it. There are a couple major differences though. When we counted the red cells, we used the inside of the hemocytometer grid and counted A, B, C, D, and E. In this case, actually that was 1, 2, 3, 4, 5 to be honest. In this case, we're going to count, but we're going to use a different counting area, and we're counting these large squares on the outside corners, A, B, C, and D. Okay. Again, we're counting larger squares because the white cells are not as numerous as the red cells. They hold larger volumes of fluid, so we'll have a different dilution factor, but it's done in a very similar way. So this is what the square looks like under the microscope. This would be square A, would look like this. And you can tell because you have all these multiple lines here at the right and below, and then out here, even though they don't show it, you don't have those. So you'll count this thicker white line, you count all the white cells contained in there, so it would look like this. Again, this is sort of a drawing of, we're going to use the left. If it touches the left line, it counts, and the top, if it touches the top, it counts. If it touches the right side or the bottom, it won't. That's why these are X'd out. And then what I did down here is I showed you what a typical white cell count would look like in a grid. So this is one of the grids. This is a B or D. I can't really tell the rest of the picture up there what it is. It's likely D, right? Because these are both light. So this is grid D. And you would count all the cells in here. And again, because we lyse the red cells, unless it was debris like this or this, we would count that. All we're doing is saying, is it a white cell? So you count the number of cells just like we did in ABCD. So looking at this one, right? I think that makes a little bit, looks like a little bit in the cell. So that'd be 1, 2, 3, 4, 5, 6, 7. I don't know, it looks like it could be damaged cell, 8. Those 9, 10. Okay, so there, that's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Those little dots aren't cells, 24, 25, 26, 27, 28, 29, 30, 31, 32. So we got about 34 cells here. We expect most of these grids to be about 25 to 50. And just like we did before, we would add them up and then multiply by the dilution factor. In this case, instead of 10,000 like it was for the red cells, it's 50 for the white cells. So again, to make math easy, let's say that we had 50 in each one of these. So there's 50, here's 50, here's 50, here's 50. That would be 200 total, times 50 would be 10,000. When it says the range for white cells, it's 5,000 to 10,000, not literally 5 white cells to 10,000. And this is per microliter of blood. So that's the white cells. And it's called a total white cell count, and we'll figure it out, very similar to the red cell. The next part is called a differential white cell count, and this one's different, hence the name. And what we're going to look at are the different types of white cells that we can encounter in the blood. And what we want to know is, we want to know, do they have a normal percentage in the blood like we would expect? So here is it's a photograph that's sort of a little bit contrived, I'm sure. But this shows the different types of white cells we're going to encounter. And what we have to do is we have to make a blood smear, stain these cells so that we can count them, and then go and count them. So making the blood smear is kind of difficult. You take a little tiny drop of blood and put it on a slide towards one end. And then you take another slide and start in the middle. And you take that blood and you drag it towards the short side. So you'll see here, you drag it towards the short side. And then what you do is you push it across the slide as far as you can and drag the blood across it. The biggest mistake students make is they put too much blood on the slide, and you won't be able to see anything because the blood will start to coagulate, and it'll squeeze the white cells in between the red cells. Remember, the red cells are 500 to 1,000 red cells per white cell, and actually squeezes the nucleus out of the white cell, and you can't tell what it was, what type of white cell. And we're going to use the nucleus in most of these situations to help us determine what type of white cell it is. So you make a blood smear. So again, you start in the middle, put the blood towards one end, you pull it back towards the edge, and then you push long ways across the edge and try to drag the blood behind you. When we do that, we would let it dry, and then we would stain it. Now, the staining procedure, right, will take place when we look at how we do it. But first, kind of just look at the blood smear. So you put a little tiny drop of blood. You start in the middle, right, and you pull back towards the short edge. Let the blood go all the way across the slide and then push forward. It's a lot harder than it looks on the video. But then what we're going to do is we're going to stain it. When we stain it, we have these different solutions. We have a fixative solution, and you would dip it in the fixative solution to fix the cells on the slide once they've dried. And then we would put it into solution 1 a couple times, solution 2 a couple times, and then wash it off. We'd let it dry, and then we would look at the white cells under the microscope and identify them. This is sort of what it would look like. So here are the red cells. Look at how numerous they are. They are lighter in the middle because they are biconcave discs, so they're not perfectly flat. So they look lighter in the middle. The little dots you see scattered around are the platelets. Notice there's relatively few of those, but there's more of those than there are white cells. And here's the different white cells that we see. All right. So when we look at these white cells, we're trying to go out to the feathered edge. Right here in the middle, they're hard to count. So we're trying to go out here to the feathered edge. And we're going to try to identify the white cells. And in a perfect world, you would count 100 of them, and you would mark what type you have. So from a standpoint of observation, when you look at the microscope, the most numerous white cell you're going to see are neutrophils. They make up, in most cases, 60 to 70% of the white cells. So you're going to see half to 2/3 of them are going to be neutrophils. And neutrophils have a couple characteristics that kind of look at. One, they tend to be like the middle size. I'll kind of go over that in a second. So I might as well do it now. So here's the middle size. I think of the neutrophils like the size of a nickel. All right. Basophils, about the same size, about the size of a nickel. Eosinophil, about the size of a nickel. So all the ones that end in phil are all kind of the average middle size. The two agranular sites, the ones that end in site, are different sizes. If you look right here, you can see that the lymphocyte is smaller than the other ones, and the monocyte is larger. So in terms of money, I think of the neutrophil, basophil, and eosinophil being about the size of a nickel. The lymphocyte is about the size of a dime, and the monocyte's about the size of a quarter. So that's going to help sometimes in identification, is looking at those sizes. The other thing it's going to look at is whether they have granules or not. If they have granules, what color are they? And then what's the shape of the nucleus? So we'll go over that as we look at this. So neutrophils, again, are called neutrophils because they have neutral staining granules. So they really don't look like they have any granules when we look at them, especially when we look at them in, at the 10 times lens or even the 40 times lens. But the one really main distinguishing characteristic of neutrophils is they have a multi-lobed nucleus. So if we look here, we see 1, 2, 3, 4, we see 5 lobes in this nucleus, right? And usually it's going to have 3 lobes or more. And if you see a white cell that looks like that, then it's invariably a neutrophil. And like I said, they're the most common, and in some people, every 2 out of 3 white cells that you count are going to be neutrophils. Might as well just go in order. The monocyte is an agranular site. I'm not really sure why they put them in this order. The monocyte are the largest cells. They don't have any granules in the cytoplasm. But what they typically have is they have a big horseshoe or bean-shaped nucleus. Okay? And so these are pretty easy to identify because they tend to be fairly large. The nucleus doesn't stain as dark typically as the other one, so it's not as dark as that, not even as dark as the lymphocyte or the eosinophil. So they have these pale staining nuclei, largest white blood cell, nuclei horseshoe or bean shaped. That's the monocyte. They make up about, depending on who you read, 3 to 8 or 4 to 8% of the total white blood cells. The basophils are the least numerous blood cells that we see. They're called basophils because they have these dark staining granules. So they're a granulocyte because they end in the name phil. And they have these dark staining granules. That's where baso comes from. And sometimes it's hard to see the nucleus. We can see the nucleus in this picture, but oftentimes the granules are so consistently dark that it's hard to see the actual nuclei, so they're said to be occluded. But the basophil has these dark staining granules, and oftentimes it's impossible to distinguish the nucleus. But if you do, you often see an S-shaped nucleus. This one's really not S-shaped though, but you often see an S-shaped nucleus. At least it's usually bilobed in some way. Basophils are very rare. They make up, books will say 0 to 1% of your blood cells, and typically less than 0.5, which means that in order to see a basophil, you might have to literally count a couple hundred cells before you find a basophil, and they're relatively rare to find in lab. The lymphocyte is the next one on this list. The lymphocytes tend to be the smallest white blood cell. They tend to have the largest proportional nuclei to the cell. So notice the nucleus here in the lymphocyte makes up most of the cell. And then this thin rim of cytoplasm, no granules. So it sort of looks like a little eyeball to me. But the lymphocytes are the second most numerous component of the white cells. And they make up about 20 to 25% of the white cells. And then the eosinophils, they're called eosinophils because they have reddish staining granules. Eosin is actually a Greek word for the color of dawn. And they typically have these bilobed nuclei. And they make up about 2 to 4% of the total white cells. So they're identified fairly easily by the reddish granules and then that bilobe nucleus. So looking at, a mnemonic from anatomy that most people learned and probably even remember, is you go from the most numerous to the least numerous white cells. And you have a little mnemonic: never let monkeys eat bananas. And so that's from the most to least numerous in terms of the percentage of white blood cells. So N, never, neutrophils, 60 to 70%. L, let, lymphocytes, 20 to 25%. Monkeys, M, third most numerous, that's the monocyte at 3 to 8%. Eosinophils, that's eat, right? That's 2 to 4%. And then the least numerous, the basophils, that's 0 to 1%. So basically, you would count 100 cells and just say, oh, I found 62 neutrophils at 62%. Oh, I found five monocytes. That's 5%. Oh, I didn't find any basophils. I found 21 lymphocytes, and I found, 4 eosinophils or whatever, adds up to 100. I wasn't doing that math in my head, but that's the type of thing you would look and say, is it a normal white cell count? And this is sometimes very useful in trying to figure out if someone's sick, what is actually causing the problems the person is having, what's causing the disease. And so that's what we see with the differential white cell count. So here's the table, and just count the number and then do the total and figure out the percentage. You could count as few as 50, although you don't get very accurate results, and really should count as many as possible. But in laboratory, we'd probably count 50. And some days, depending on how well the stain is and how much time we have, it's difficult to even find 50 of these white cells. So like usual, the blood stuff we'll have to clean and throw in the sharps and make sure we wear gloves and stuff. And then we'll make another video for the white cell discussion.